Alright, so this should be a pretty short video, probably about 5-10 minutes, and it's really more conceptual, right? The next video we'll get back to start and make our bed, and then we'll do some more videos for the bed, for the next class session. But I did want to get you some conceptual stuff, actually in video format. One of the things we talked about last week in the conference is triangles, right? Quads and n-gons, right? So of course a tri is a triangle. That really just means if you hold down the right mouse button, right, because that brings up your selection types, you go to vertex, it's a polygon that's got 3 vertices. Tri, right? Triangle. Triple, right, is 3. So 3 vertices. The triangle polygon is actually the building block polygon. I'll kind of talk to you guys about it in a minute when we talk about normal direction and things like planar, coplanar, non-planar. Why a triangle, in many ways, is actually really cool. They're just not easy to model with. So a triangle is actually quite a reliable polygon in terms of deforming and looking nice, but it's not easy to model with, whereas quads are. So sometimes if you guys see models that are triangulated, particularly for video games, that's because usually they do want to triangulate them when they're ready to go in the game engine. Rendering engines themselves, like Arnold, actually render in triangles anyways. It's just a lot easier to model in quads. So quads is kind of like the Goldilocks polygon. It's the most practical all-around one. So quad, of course, or quad is short for quadrangle. Quadrangle is any polygon that's got 4 vertices, right? Squares, rectangles, right? So if I was to do this to it, that's a rectangle, right? If I was to do this to it, parallelogram, but it still has 4 vertices, right? It still has 4 vertices. So a quad or quadrangle is a polygon with 4 vertices, just like a triangle is a polygon with 3 vertices. The last one here is what we call the n-gon, right? And remember, that's n slash gon, right? Because polygon is P-O-L-Y-G-O-N, right? Polygon. N-gon is really just n is variable, right? It could have been like x polygon or y polygon, although that would have been confusing with the x and y z-axes, right? Your Cartesian space. Remember, this is your Cartesian space right here, right? There's kind of these slightly too darker grid lines. That's your origin, right? 0, 0, 0. 0 for the x, 0 for the y, 0 for the z. And you've got positive x, negative x. That's kind of x1, x2, x3 according to the grid units. Negative x1, negative x2. So this is very much like it would be in a geometry or trigonometry class when you're graphing equations on the x and y axis, right? Except that we have the z to make it 3-dimensional. So n really just stands for variable, right? You can put any number in there. But basically, the smallest n-gon you can get is a polygon with 5 vertices, right? 5 vertices. That's an n-gon, right? Believe it or not, if I wanted to, I could actually make this into an even bigger n-gon, right? Now that's got actually 6 polygons, right? So believe it or not, an n-gon is really a polygon that's got 5 vertices or more, right? Anything that's bigger than a quad has more vertices than a quad, which would be 5, 6, 7, 8, 10, 20. That's an n-gon. Now, remember, the n-gon is the worst of all polygons, right? It can become highly unpredictable as you deform it, right? Something I'll talk about in a minute or so. Even though triangles deform quite predictably, they're not really easy to model with. Quadrangles kind of have the best of everything, right? They are quite predictable. Certain tools work really, really well with them, which we'll talk about in a minute. That's why this video is going to be like 5-10 minutes. It's a conceptual video, right? The nice thing is you don't actually have to do any of this. You just kind of watch it, and it's nice to have this kind of video lecture kind of inform. The n-gon itself can actually become quite non-planar and behave really, really weirdly, right? So I'll talk about that more in a minute when we talk about normal direction, planar, coplanar, non-planar. But one of the things about a mesh is you'll notice I've kind of created some quads right here, right? Kind of quads going along in a pattern. Now, the way the multi-cut tool actually works, right? Your multi-cut. The way the multi-cut tool actually works is by going from opposite edge to opposite edge, right? So if we turn on multi-cut and I hold down Control, you'll notice it goes kind of opposite edge to opposite edge. So you'll notice when it kind of gets to like here, right, that it's not just kind of trying to go to here. It actually goes to the opposite edge, right? So when it's actually trying to add an edge loop in, it's doing this, right? It's actually going from this edge to this edge, the opposite edges. These edges right here, since they touch this one, right, they're adjacent. Pretty much all software will automatically rule these out, right? So it's only looking for that one. So it can predictably add an edge loop in here, right? So you see that's the way multi-cut works, right? It's kind of whatever edge you're putting it over, it's going to go in perpendicular, and it's always going to look for the opposite edge. So these ones will always be discounted because they're adjacent. They actually touch it. This one doesn't. It's opposite, right? And that super reliably and predictably allows you to add an edge loop in, and it kind of follows the actual opposite edges, right? It doesn't try to cut through here. Now, what if I was to triangulate this? So I'm going to go to object mode here really quick, and I'm going to go to triangulate to turn this all into triangles. All triangles, right? Now if I go to multi-cut, you notice how it's not doing anything? That's because a triangle, if you look at it here, it doesn't have an opposite edge, does it? Right? There's no opposite edge. These are the only two edges, and they're adjacent. So it doesn't know where to go, right? It doesn't know what to do, right? So that's one of the biggest problems with triangles, right? And why they're hard to model with. One, if you wanted to just extrude out a square, a quad, you'd have to select two triangles. But also things like selecting edge loops and adding edge loops don't work well on a triangulated mesh. That's actually one of the big reasons why we don't model in triangles. One, it adds twice as many polygons to interact with. That makes it a little more complicated. But also things like selecting edge loops and adding edge loops are pretty much impossible on a triangulated mesh because there's no opposite edges. Even the way we select an edge loop when we double click is kind of using a similar rule, just kind of based on the number of edges coming out of a single vertex, right? So you'll notice you can't select edge loops, you can't add edge loops on a triangulated mesh. That's one of the reasons why we don't like modeling with triangles. So keep that in mind about things like multi-cut and how that's working and why triangles, right? When with an n-gon, like if I go to multi-cut here, you'll notice it works on these because there's always an opposite edge. Even when it's a single quad, it'll put an edge loop in because there's always an opposite edge, right? Triangle, there's none. When it comes to an n-gon, right, you select that, these ones will be automatically discounted because they're adjacent, right? But now we have 3 here, right? And if it was a 5-sided instead of a 6-sided, there would be 2. So once again, with an n-gon, you notice how it's just not allowing it to add an edge loop, right? Got multi-cut, I'm holding control down. So that's another reason why we don't like n-gons, is much like triangles, we can't add and select edge loops easily on it. So that's kind of one of the reasons why we like a quad, right? The selecting and adding edge loops works really, really predictably and actually works on meshes that are largely quad-based. An already triangulated mesh is not going to do that. If you have like 1 or 2 triangles on a mesh that's mostly quads, not a real big deal, right? You have 1 or 2 n-gons on a mesh, not a big deal, right? And we'll talk about, particularly where n-gons can be used on like buildings and things like that when we do our room. But we really like to have a strong quad bias. We really prefer quads because certain tools like multi-cut to add edge loops and even just selecting edge loops work really well and predictably on quads, whereas they don't even work at all on triangles and n-gons. Now, one of the last things I want to talk to you guys about in this video conceptually is normal direction, right? I kind of briefly talked about it the other day. I'm going to go to display, right? And you guys don't have to do this, right? I'm just kind of pointing this out. And I'm going to go to face normals, right? So I'm going to go to display polygons face normals, so to show the normal direction. Now you'll see that the normal direction is really just kind of a perpendicular little darker green line coming off of the mesh, right? The polygon right here. So really what your normal direction is, and I'll just go to face mode to select this. Remember E for rotate, of course. You'll notice that when I rotate this, this normal direction is always lined up with it, right? So normal direction is really just the direction your polygon is pointing, right? So the polygon's facing this direction. That's the normal direction, right? Here's one of the cool things about triangles and what makes them reliable polygons. Even though you don't really want to model with them because of not being able to select and add edge loops. One of the cool things is even if I move a single vertex, right? You notice how the normal direction is always reliable? Doesn't matter where you're pointing this. Because one of the cool things about a triangle is no matter how the actual mesh is oriented, how the polygon's oriented, all of these vertices occupy the exact same plane, even when they're rotated, right? So one of the cool things about triangles is they're always planar, right? So you're never going to get a weird dent or divot that's going to kind of do weird stuff. when you animate. If this is on a building that doesn't animate, not as much of a big deal. On a character creature that squashes and stretches and deforms, definitely becomes much more of a concern. So one of the cool things about triangles is triangles are always planar. This polygon's always going to deform really, really predictably. They're just not easy to model with, right? So triangles themselves are actually quite reliable polygons. In fact, they're kind of the building block polygon. They're just not easy to model with, so we don't model with them. But a triangle is always planar, right? No matter what the angle is, if you look, all these vertices are still on the same plane, right? And plane just means flat, right? That's what planar means, flat. So it doesn't matter if you're just even moving single vertices, that normal direction is always going to reliably point the way it's supposed to point. So that's one of the cool and great strengths of triangles, is that they are planar. Now in this case, I'm going to take this quad, and I'm going to move some vertices here, right? And I'll just go to display polygons, and I'll just kind of turn on face normals again for this one. Make sure we're in object mode when we do it. Display polygons, face normals. Remember, you guys don't have to do this. This is just a concept video. Now you'll notice that right now, and it's easier to even tell on this one, right? They're all flat, right? Now here's the thing: if I rotate these all four of them, right, no matter what angle it is, you see how they're still all flat? They're still planar. And you notice the normal direction is still kind of oriented exactly perpendicular to the polygon, right? Because this is still a planar polygon, no matter what angle it's at, right? And remember, normal direction is just the direction your polygon is facing, right? Kind of the way it's pointing. So I'm going to go back to making it flat. What if I grab a single vertex, though, and I move this? Now, all of a sudden, you'll notice that these four vertices no longer are on the same plane. This one's kind of up and away from these other ones, right? These ones are on the same plane, right? But this one isn't. This polygon has now become non-planar, right? So this is a non-planar polygon. Now quads can become non-planar. That does mean as you kind of move this around, sometimes you can get a weird bend, and sometimes it's hard to reproduce. But if I was to kind of move these around, you see how kind of that triangle kind of tries to break in different ways? You see how kind of it's doing it that way, and then if I move it down here, it's kind of going to break it that way. And sometimes when it's animating, right, it can kind of switch those on the fly. In fact, just to give you an example, once I kind of turn these into all kind of two triangles, you'll notice, and you don't have to worry about the tool I'm using, I'm just going to show it off. With a non-planar polygon, what can happen is the more it deforms, the more it gets bent and made non-planar, what can happen is it's trying to actually already triangulate it, right? You can kind of see the way it breaks, that a quad's trying to triangulate it. If I was to spin this, though, you notice how it could actually break two different distinct ways, all right? And so that becomes one of the tricky issues when you're dealing with a non-planar polygon, right? Is the fact that it can do this as it's animating, right? So a pretty low resolution character, as it's deforming, even if it's quads, it can do this, right? So that's one of the things you have to be aware of and be careful of with non-planar polygons. So the quad can become non-planar, do some slightly weird stuff sometimes, right? It is still a pretty safe polygon. Particularly the denser our mesh is, the less of an issue it becomes, because the polygons become quite small, they won't become terribly non-planar. But that's kind of what non-planar is, and what can happen with a non-planar polygon, right? It can kind of flicker, right, and kind of bounce away in weird directions. In this case, I intentionally created the triangle to show you what would happen, but you'll notice as we go back, you don't have to actually have that polygon there, and it could still kind of do it on its own, right? Kind of how it wants to bend in there. So that's kind of just one of those things to keep in mind. So planar versus non-planar. And you'll notice that, of course, an n-gon can become even worse. I mean, really watch how non-planar and really warped and distorted an n-gon can become. And the way it'll bend in weird ways, right? The more you make it non-planar. So the more vertices you have, particularly if you're doing shaping, the more likely an n-gon's to become non-planar, and it just becomes kind of chaos, right? That's why we don't really like n-gons at all unless they're like on a flat surface that never animates. One more thing just to point out, do a quick connect, is coplanar. So in this case, we do have these two polygons that all of the vertices for both these polygons are on the same plane, right? that's coplanar, right? The moment you move a single vertex off, becomes non-planar, right? And that can kind of bend this way, but also if you move it around enough, it might bend kind of another direction, right? So it can kind of start to bend on its own in ways that you aren't anticipating. So remember, planar is when all of the vertices for a polygon are on the same plane, right? They all are, even if the plane's been rotated, right? They're all still on the same plane. The moment you move a single vertex off on a quad or bigger, it can become non-planar. And even at an angle, though, when these two polygons, all the vertices are on the same plane, those are coplanar, right? So that's kind of what I wanted to get you guys across in this video, was the fact that there is things like planar, non-planar, coplanar. I wanted to kind of have you a nice video form of, hey, triangle, n-gon, quad. And now you understand one of the reasons why we prefer quads. Yes, they can become non-planar, but only so far, right? And n-gon is going to be vastly worse about that. But certain tools like adding edge loops and selecting edge loops work super predictably and super reliably on a quad, whereas they don't work at all on a triangle or n-gon. So we really still prefer quads. And we now know normal direction is really just the direction the polygon is facing. And triangles are always planar, so the normal direction is always behaving itself, right? Whereas quads can be a little non-planar and can behave themselves a little bit not so much, but it's worth the trade-off in terms of, you have half the polygons to manipulate, and things like adding edge loops and selecting edge loops work great with it, right? N-gon's kind of just the jerk, right? The n-gon is just the bad guy. It's just becoming too chaotic. There's too much going on with it. It can become too non-planar, and it still has all the drawbacks of the triangle. You can't add and select edge loops, whereas it has the negative of becoming highly non-planar. So just kind of a little about that. Just want to make sure you guys kind of had a cool concept video.